Hello students. So today we shall learn about how to write dimensional formula of a physical quantity. Okay, and now you may not know how to write or how to express a physical quantity into its dimensional formula. It is very simple. Let me do a few examples. Okay, first, then you shall try it at home. Some examples. Okay. For example, number one, volume. Let's take volume. Volume is a physical quantity. Okay. So we know that volume in relation with other physical quantities, it is simply length into breadth into height. Okay. Height, height. So length is measured in meter, isn't it? So we can put L. L stands for length, and breadth also measured in meter. It's also a length, and height L. Do we have mass in volume? We don't have. Okay, and do we have time in volume? We don't have, isn't it? We don't have time in volume. So here m will be 0 and time will be also be 0, isn't it? We don't have time. So if we express in a dimensional formula, we write like this: m 0, and what is L? It is L. We have 3 L's. L cube. Okay, L cube and time 0. So this is the dimensional formula of volume. Okay, dimensional formula of volume. This is how we write. And next, let's write dimensional formula of density. Okay, density. So what you must know that what is the relation with other physical quantities in order to express it in dimensional formula. Dimensional formula in zia don hian physical quantity dang ne na in relate dan ka shiat kha angai khalai ka poimo pera hengi chu by heart angai lo. It is no need to by heart their dimensional formula, but if you know the expression with if you know the relation with other physical quantities, then it is very simple. So we know that density is mass by volume, isn't it? Mass by volume. Okay, so here we have mass m, isn't it? 1m. And volume, we already know that we have 3 L's, but in volume we don't have time, we don't have mass, so it is simply L cube. Now, do we have time in density? Here, time. There is no time, isn't it? Time umlo. So we can write like this: m here. If we don't put anything here, that means there is 1 nani, and L, when it comes up to numerator, minus, isn't it? Okay, minus. And do we have time? No, we don't have, so we put 0. So this, along with this bracket, this is a dimensional formula of density. Okay, dimensional formula. And what about force? Okay, force. Force is mass into acceleration, isn't it? My handwriting is not so good, but I think you can see and understand, isn't it? Mass. Mass is m, isn't it? What about acceleration? We can put into another relationship again. Acceleration is velocity by time. Velocity by time, isn't it? Still, we can put velocity equals to distance by time, isn't it? Velocity is distance by time. Velocity is distance by time, isn't it? So velocity is distance. Distance is measured in meters, so it is L, isn't it? L by T. But here we have time. That means we can put like this, T. So we have 1m and 1l. Okay, but here we have T square. Okay, here we have T square. And now the final dimensional formula for this force will be m, l, and this T square if we take up, and it will be like this, T to the power minus 2. So the dimensional formula of force is m, l, T to the power minus 2. Okay, so it is very, very simple. So you can do other example like so I shall give you example. You have to do at home. Please do pressure and work, and also impulse, very simple one I shall give you, and strain. You must know that some physical quantity have no units, or we can say they are dimensionless also. You must check which one is dimensionless. Okay, which one is dimensionless. So you please do it at home. I hope you understand from this example, isn't it? It is very, very simple. The most important thing is you must know the relationship, the relation with other physical quantities. No need to learn by heart, because there are lots and lots of physical quantity, and that means there are lots of dimensional formula. It is very, very difficult to learn by heart all this and many more. So no need to learn by heart. If you understand how to write a dimensional formula, that is enough. And the most important thing is its relationship. For example, this force in relation dan can share to force le inge mass acceleration can relate dan to force ringot ka dimensional formula by heart thailo mai thaya. You may not be able to by heart this. There are lots of dimensional formula. Masse hem relation it ikan acceleration relationship kai share le chuan velocity ne in relate ti sheleta velocity chu inge distance by time sheleta ni tiang khan a chong zelin. So slowly one by one, step by step you do it. In the final dimensional formula comes out. So it is very simple. Okay, that is all for today.